Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the structure of the atom. In our last lesson, we discussed the Bohr atomic model and how electron configurations are expressed with this model using the 2n² formula. Today, we will continue our exploration of the atomic model by examining the quantum mechanical model. Let us begin. During the 1920s, scientists discovered that electrons behave similarly to waves. This realization led researchers to believe that the exact location of an electron could not be pinpointed. Thus, a new model of the atom was required to account for this fluctuation in the location of electrons. It was named the quantum mechanical model of atoms. In this model, electrons are described in terms of the probability of being found in certain regions of space around the nucleus. These regions of space are called orbitals. Orbitals are defined as a particularly shaped volume of space where the probability of finding an electron is at its maximum. Similar to the Bohr model, the quantum mechanical model states that electrons exist in a series of energy levels or shells represented by the principal quantum number n. The higher the value of n, the farther the electrons are found from the nucleus. Where the quantum mechanical model differs is in that it introduces the concept of a sub-level. A sub-level is an energy level that exists within the shells already present in the Bohr model. For the atoms of the known elements, there are 4 types of sublevels, which are designated by the letters S, P, D, and F. The number of sublevels within each shell is equal to the numerical value of n. For example, the number of subshells in the shell for which n equals 1 is 1. And in the shell for which n equals 2 is 2, and so on. This table helps to illustrate the concept of sublevels within the atom. The quantum mechanical model suggests that each subshell contains a given number of orbitals, each of which can only accommodate a maximum of 2 electrons at a time. However, the number of sublevels grows with each energy level. Thus, sublevel S has 1 orbital and can hold a maximum of 2 electrons. Sublevel P has 3 orbitals and therefore holds a maximum of 6 electrons. Sublevel D has 5 orbitals, and so it holds a maximum of 10 electrons. Lastly, sublevel F has 7 orbitals and holds a maximum of 14 electrons. Students, now that we have explained the basic concepts of the quantum mechanical model, let us do an activity. Here is a list of terms we have discussed. Please write down a definition for each one.
Students, let's get ready. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to define the terms correctly? Let us look at each. An orbital is defined as a particularly shaped volume of space where the probability of finding an electron is at its maximum. A sublevel is an area around the nucleus that exists within the shells of an atom. Sublevels are composed of orbitals that can hold a definite number of electrons. The amount of sublevels in an atom is determined by the amount of shells present in the atomic structure. Main energy level refers to the electron shells of the atom. In a given atom, the main energy level is indicated by a variable n. The main energy level is the shell that is central to our calculation. The principal quantum number is the number representing the main energy level. Thus, energy shell 1 would be expressed as n equals 1. If you were able to define the terms as they appear here, you are correct. Great job. Let us do another activity. Pictured here is a carbon atom. Based on the quantum mechanical model, how many orbitals does a carbon atom have in total? How are these sublevels labeled? What is the maximum number of electrons that can be accommodated by a carbon atom? You may begin.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. If you have been taking notes, this activity is very simple. To answer the first question, we can refer back to what we know about sublevels. The amount of sublevels is related to the principal quantum number, which in this case is 2. This means that the first 2 sublevels, labeled S and P, are present in the carbon atom. Since sublevel S has 1 orbital and sublevel P has 3 orbitals, we can conclude that there are 4 orbitals total. From this, we can also figure out the maximum capacity for electrons in a carbon atom. We know that the shells in stable orbit can accommodate up to 10 in total, because shell K can hold 2 electrons and shell L can hold 8. Since each orbital can support 2 electrons, we can conclude that a carbon atom can sustain a maximum of 10 electrons. This is the end of our lesson. Today, we have learned about the quantum mechanical model of the atom and the differences that it has from the Bohr model. We learned about the sublevels and orbitals within the atomic structure and how they are expressed when labeling an atomic diagram. I hope you have found this informative. Teacher and students, the next 3 lessons will be covered by the classroom teacher. Until next time, thank you, teacher. Thank you, students.